Okay, very good afternoon, all present here. I hope all of you are doing well. Good afternoon to me. So, anyone can summarize what you discussed in the last class? Anyone can summarize what you discussed in the last class? Okay. So, in the last class, okay, we discussed about the concept called as topological sorting. So, in the topological sorting, we discussed about what is topological sorting and what are the techniques which are comes under the concept of topological sorting, and what is the routine which is used to find the or solve the topological sorting, and how it is effectively used for real-time applications. Okay, so these are sorting. Okay, so again I will brief that thing. So what is topological sorting means? So for example, if you are having n number of machines or n number of nodes, so all the nodes are arranged in a particular physical locations. Okay, all the nodes are arranged in a particular place along with its physical location identification. Okay, so that thing is called as topology. Okay, so what is meaning for sorting here is topological sorting means, so here we are having n number of nodes, so all the nodes are arranged in a particular order in the format of graphs. So how these nodes are interlinked together and in which way these nodes are arranged together. Okay, so that is the thing which we are calling it as a topological sorting. Okay, so the thing what we discussed is the routine of the topological sorting mainly follows based on the concept of vertex and edges. Okay, so simple thing what I told in the last class means, so the routine for converting the given graph into topological sorted graph is nothing but, so listen, first how you are going to say the graph is, seek the graph is, listen. So see here, to all I hope. Okay, so these are things we discussed in the last class. Okay, so how the ordering is done with the help of the starting means, listen. First, you have to see or check the node which is having no incoming edges. Okay, so in a given graph, you have to check for the thing a graph which is having no incoming edges. Okay, so you have to remove the particular node from the graph which is having no incoming edges. Okay, so see in the picture here we are having two nodes which is having no incoming edges, the nodes 1 and 2. Okay, so first you will check for the node which is having the lowest priority.
Sir, not able to see the pictures.
searched. Okay, so now memory, whenever it is to be retrieved by the user, so then they are going for the option called as search options. Okay, okay, I hope all of you understood. Element is stored in a computer memory already. You are going to retrieve the particular element from the computer memory. Okay, so how the elements are to be searched in a particular order, and in what way the elements are searched in a particular order. Okay, so that is the thing which we are going to see. Okay, so for picking up an element or retrieving an element, we are going for the concept called as searching an element from the list. Okay, then followed by we are having two kinds of search operations in a graph. So one is called as depth first search, another is called as breadth first search. Okay, so there are two types of searching operations in a graph. One is called as depth first search, another one is called as breadth first search. Okay, so for example, I will tell one simple example so can you can easily identify. So what is the concept of depth first search and breadth first search? Okay, uh, wait. Okay. Okay. So let us consider. Okay, let us consider there is an dig. Okay, there is consider there is a dig which is there in a place wherever you are going. Okay, for example, if you are walking in a particular road, you are seeing a dig. Okay, in a particular road. Okay, so in the dig, okay, you are placing or are you something, you are placed some object inside the dig. Okay, and you are going to search whether the object is present inside the dig like that. Okay, சொல்றது புரிஞ்சுங்களா? Okay, for example, நீங்க ரோட்ல டிராவல் பண்ணிட்டு இருக்கீங்க. ஃபார் எக்ஸாம்பிள் சடனா என்ன பண்றீங்க, உங்களுடைய ஏதோ ஒரு ஆப்ஜெக்ட் வந்து ஒரு ஒரு குழியில விழுந்ததுன்னு வச்சுக்கோங்களேன். ஓகே, ஸோ ஹவ் இட் இஸ் டு பி சர்ச், அதை எப்படி சர்ச் பண்றது எடுக்கிறது. ஒன் இஸ் யூ ஆர் கோயிங் டு சர்ச் த எலமெண்ட் ஃப்ரம் டாப் டு பாட்டம் ஆஃப் தி டிக், அதாவது அந்த குழியினுடைய ஸ்டார்டிங் பாயிண்ட்ல இருந்து எண்டிங் பாயிண்ட் வரைக்கும் சர்ச் பண்ற ஒரு ஆப்ஷன், டைரக்ட் சர்ச். ஓகே, the search nothing is nothing but it is done with the help of the searching in the order of vertical manner, அதாவது டாப்ல இருந்து பாட்டம் வரைக்கும் டைரக்டா சர்ச் பண்றது. Okay, so there is another option of searching is nothing but the horizontal ordering of searching. Okay, it means you are searching in the format of some bitwise. Okay, for example, on the dig உடைய horizontal order நீங்க sort பண்றது or search பண்றது. Okay, so that is called as breadth first search. Really keep this as a simple example. அதாவது depth first search means you are going to search the element from the root node to the leaves, root node to the end node, or source node to the destination node. What is the meaning for breadth first search means you are going to search the element from based on the size of the breadth order. Okay, or based on the size of the ordering of breadth. Okay, okay, I hope you raise your hands here.
Sir, PPT is not visible, sir.
I hope the Anil Patel. So
Yes,
what's
sir.
the doubt here?
Sir, PPT is not visible, sir.
What ma?
PPT is not
PPT
visible.
not visible.
Yes, sir.
Okay.
Sir.
Okay. No, no. Now only I am displaying the PPT. Okay. Now only I am displaying the PPT. Yeah, yeah. Now only I will display the PPT. So now I told only the examples. Okay. Now is it visible?
No, sir.
How is it visible? Anil Patel, how it visible?
No, sir. Yes, sir.
Okay. So, so that is the thing is called as breakfast search. Okay. So now we are going to see the concept called as breakfast search in a graph. Okay. So simply it is called as BFS, okay, in a graph. Okay. As I told earlier, so there are two ways of searching in a graph is possible. One is breadth first search, another is breadth, another is called search. So the BFS is called as first search.
Sir, voice is breaking, sir.
Okay. So this BFS mainly stands for breadth first search. Okay. This BFS mainly stands for depth first search. It is mainly used for traversing a graph or searching a graph. Okay, the traverse in the sense you are going to visit all the nodes in a graph, which is to be traversed for finding a particular element in a graph. Okay, so this breadth first traversal can be implemented using the QADT. Okay, so the breadth first traversal is implemented using the concept of QADT. So the QADT in the sense what the arrangement of the nodes and movement of the nodes, we are going to use the thing called as first in first out manner. Okay, the searching operations also like follows the things called as search in first in first out manner. Okay, then once the traversal is completed, okay, once the all nodes are visited, it tells about the traversal operation is completed, so the traversal is to be ended or the traversal is to be stopped up to this. Okay, so that is the concept of breadth first search here. Okay, now again I will tell simply, okay, about the graphல பாத்தீங்கன்னா we are having two types of search. One is called as depth first search, another is Okay, so it is the routine. Okay, simple routine which shows the concept of breakfast search. Okay. So see here, it is the routine for the concept of breakfast search. Okay. So initialize all the nodes. Okay. Initialize all the nodes. Okay. Initialize all the nodes with the status 1. Okay, it is nothing but a ready state. Okay, so the root node is always in the location of ready state whenever a new search operation or traversal operation is to be processed. Okay, then next. Okay. So after that, you are going to set the status of the node is in the location of 2. Okay. So see here. Okay. So it is the order of arrangement of how the breadth search is happening in a graph in normal thing. Okay. So see here. So let us consider this graph, okay, which is shown in the screen. So for this graph, okay, so there are some different nodes which are available in the graph. Okay. So how the breadth first traversal is happening means, listen, here the search is happening in this order, okay, like this. First it is to be marked, okay, so the A is to be marked here. The next you got to put a line like this, and it is scanned, it is BC. Then next it is to be put a line like this, it is E, and it is E, it is this line, okay. The next one it is FK, then it is like this, okay. So listen, so this is the way in which the graph is scanned, okay. So see here, so here they shown the various level of breakfast level, search levels of graph. This kind of searching is nothing but a breadth first representation in a graph. Okay, breadth first search in a graph. Okay, then followed by we are having some different applications. Okay, followed by we are having some different applications. Okay, so listen. So all of you see the screen. Okay, here you are going to see here you are seeing a graph. Okay, which is shown here. So how the graph representation is done with the help of arrays. Okay. So see the graph which is shown in the screen. Okay. So first the node A. So see here it is scanning. It is scanned in this level. Okay. Listen. First the node A is scanned. Okay, by this order. Okay. Listen first. The A is scanned like this. Okay. A is scanned and is to be filled in the array. The next one, the node B and C is scanned and it is to be rotated, loaded in the array like this. The next one, you are having C. So next one, C and D is to be loaded. And next one, and F is to be loaded. Okay. So this is the way in which we are arranging our data in a array structure for completing or filling the data elements. Okay. So it is the thing or way of representation of allocating or storing and placing the elements in an array. Okay. So I hope all of you understood. I hope all of you are getting clear. Okay. So it is the thing, okay, which is shown to the process of okay. So it is the thing which is shown in the screen, okay, which shows the concept of how the breadth first searching concept is working with the help of graphs. Okay. The next one, it is very important. Okay, so how the breadth first search operation, which mainly helps for the collection or operation of working of the graphs in the real-time applications. Okay. So these are some of the real-time applications which mainly supports for the public for providing the opportunity and process. Okay. So first one, the breadth first traversal is mainly used in the location of concept called a GPS navigation system. Okay. So what is GPS means? It is nothing but a global positioning system. It is nothing but I hope all of you are using this concept in your cars or some electrical bikes like that. Okay. So it means nothing but whenever a person is moving from one place to another place, so it is easy to track the persons and identify the persons where he is going and right now like that. Okay, based on the location of the person, it is to be identified. The next one, followed by this one, we are having the Google Maps. The Google Maps is also working in the concept of breadth first search in a graph for searching a particular location or searching a particular place where the user is going or where the user is moving. So based on the user's command, where the place is to be marked and where he is going to reach like that. The next one is mainly used in the concept of digital maps. Okay. So the digital maps is also like the Google Maps, which mainly supports for the transmission of persons or traversing a persons moving from one place to another place, and it places the students in a particular locations. The next one is it is mainly supports for the concept of wireless communications. So any kind of communications can be taken place with the help of a wired or wireless manner. So in the wireless communications also it is mainly provide to see the things which mainly supports for the transmission of data or searching or traversing the data. The next one, it is mainly used in the concept of data mining. So it is mainly used to mine the data which is stored in a particular repository for collecting and accessing the data in a particular time. Then it is mainly used in the concept of maze games. So for movement of elements or for finding the array pixels are combining the array pixels. The maze games mainly use the concept of breadth first search for moving and locating and tracking the elements from front to back or back to front or in an order of some diagonal manner or some vice versa manner like that. The next one, it is mainly used in the concept of social networks. So as I told earlier, the main real-time applications of the graph it is nothing but the traversals. The main traversal and it is mainly based on the concept of social networks. Okay, so in a social networks, I already told we are having some different things which are connected together, and all the things are to be visited at least once means. Okay, it shows it works with the concept of graphs only. Okay, or traversing the graph operations only. Okay, so these are some of the applications what I want to insist you. Okay, and followed by okay. So now we are going to, okay. So all of you see the screen. Now we are going to solve the assessment. Okay. So all of you read. So the for the first question, the data structure used in standard implementation of breadth first search is. Okay. The data
You,
structure used in standard implementation of breadth first search is. So what's your answer? The first option
you,
is
sir.
stack.
Option B.
Next option is queue. Next option is linked list. Next option is tree. So what is the answer?
Q.
So if you are not possible or able to talk, you can chat. Okay, you can use the chat window and you can tell your replies.
Sir, Q, sir. Q.
And you type the answer or type the option. Okay, what is the answer? Okay, Anil Patel told it is Q. Okay, it is very good. Okay, it is correct. Q. Okay, so based on the breadth first search. Okay, the implementation is the very good easy implementation which helps for the operation of Q is not, breadth first search is nothing but a Q. Okay, QADT prevails the better way for implementing the graph data structures. Okay, breadth first search operations. The next one. Let us consider the second statement. Okay, so a person wants to visit some places. He starts from a vertex and then he wants to visit every place connected to this vertex and so on. So what algorithm he should use? Okay, a person wants to visit some places. He starts from a vertex and then wants to visit every place connected to this vertex and so on. So what algorithm he should use? Okay. So based on the statement, we are having four answers here. Okay. So for this question, the answer, you are having two answers here. So what are the answers? What are the right answers here you are having? So both this, okay. So the question which supports for the both the answers of the option A and B, okay. It generally supports for the concept of both depth first search and breadth first search, okay. So here it will tell you the solution for this question is the option A and B, okay. Both supports for the concept of checking and traversing nodes, okay. And these are some of the references, okay, for this corresponding topic. And if you are having uh, you have to take this, and it will gives you the correct contents for the preparation of the various topics, okay. So up to this we discussed about, so what is the concept of breadth first search and how it is to be working like that. Then the depth first search, okay, the depth first search is the vice versa, okay, or it is in the opposite version of the depth first search. So how it is working is nothing but, first you have to identify a root node. So from the root node you are going to search for a nearest node which is having the shortest path, and you have to mark the nearest node. And for identifying the another nearest node or visiting the another nearest node, you have to again come with the root node and followed with another node and followed with another node, like that, okay. So your operation is always starts from the source to destination up to it is having n number of nodes, like that, okay. If it is a breadth first search, if you are traversing in a or scanning in a breadthwise order, but here in a depth first search you are going to move from the root node to all other nodes in all time, okay. So based on the time complexity, the depth first search takes more time compared to the concept of breadth first search, okay. So the concept of depth first search is not mainly used compared to the breadth first search, okay. Then the last thing, okay, so some of the applications of graphs which is used in real time. So the graphs are mainly used in the concept of transportation networks, okay. Sometimes called as, it is used by Google Maps, then it is used by Apple Maps, or sometimes by Bing Maps, okay. So it is used to represent the transportation network in a real time, okay. The next one, the graph is mainly used to represent the molecular structure of a human being, okay. So the molecular structure are represented in the format of some nodes and edges, which is shown in the screen here. So all the molecules are bonded together and which forms in muscles, okay. So the real-time example of the graph which is used for representing the molecular structure of human being. The next one, it is used in the concept of map coloring. So I hope all of you know the famous problem which is called as graph coloring problem or map coloring problem. So which is used to map the showing the things which is easy for the conversion of the graph data structures. Okay. So see here, it is a traveling salesman problem, which is if you are considering a salesman, you have to visit all the cities for sell his product. Okay, so while he is going to sell this product, you are going to beat the constant which is given by the people or person under the concept of graphs. The next one, the airline network. The graph theory is mainly used in the concept of flight networks or airline network. So it is used to connect the countless number of cities, and it supports for the most efficient way for it is mainly used in the computer field for finding uh, or using the Google Maps, Yahoo Maps to find the shortest path or shortest route to for a people to move from one place to another place. Mainly supports for the concept of navigation systems. It prevails the way to achieve the things. Supports for the concept of navigation systems or the traversal concepts. Then the graph theory mainly prevails the way of connecting the data through the network, computer network. The computer network is nothing but connection of interlinked computer together, which prevails the way for connecting a data transferring between one place to another place like that. Okay. So there is some connection between the edges, and it plays the device for the routers and also the personal communications like that. Okay. So the connection between the devices prevails the way for achieving the best data transfer and gives the solution for each link device. Okay. Then it is mainly used in the concept of databases. So for representing the ER diagrams, okay, entity relationship diagrams, and mainly representing the dependency of tables in databases like that. And it is mainly also used in the concept of social networks. Social network means it prevails the way for achieving the interconnectivity of networks with the representation of solutions over social media along with the Facebook or Twitter or Instagram, etc., which connects together in a defined manner. Okay, so the link between the this minimum spanning tree mainly supports for finding the shortest path in a graph. It also reduces the cost of traveling from one node to another node. Okay. Then it prevails the better way for achieving the originality of data transfer along with its data traversing and traversal process. Okay, so the mini span tree mainly supports for the cost cutting operation for achieving the graphs and transferring the graphs in a well defined manner. Okay, which prevails the originality of transferring the data messages in a repeated thing. Okay, so based on this, you have to provide the things or routines and connecting the interconnection of various things among the graph nodes in a defined way. Okay, so I hope all of you understood the topics. Okay, so can anyone summarize so what we discussed in this class? Can anyone summarize what we discussed in this class? Okay. So up to this, we discussed about the topics. Today's topics is we continue with the topological sorting, and followed by we discussed about the depth first and breadth first traversal, and we saw about some of the applications of graphs. Okay. So up to that, we stop this class. Okay. So in the next class, we are going to see the concept of minimum span entries, which mainly supports to reduce the cost cutting techniques for the graph to transferring the data and messages in a given order or in a given manner. Okay, so thank you all. Okay, and we'll meet in the next class. Okay, thank you all. I want to leave the meeting. Thank you, ma. Okay,
Thank you, sir.
thank you, ma. Thank you.